what comes in a box this size and supposedly can replace this boiler, oil-fired boiler, this 40-gallon hot water tank, and this 275-gallon oil tank. All right, I've did a quick cleaning of the wall. We got these two pieces of wood ready to be put on the wall. I made sure they lie flat on the wall, so see if I can pick one up here. Okay. Here you can see that the cement's got those from the forms. So these two pieces, they're about the same length. And they will mount to the wall. I'm going to try to use my ram set here. I've got my hearing protection, got my goggles. Here's the unit, the nails in here, those are the loads. After I put that wood on the wall, then I'm going to put the plywood on the wood and end up making a back wall like we. This unit uses 3/4 inch, which is the same as this unit here. And we need cold water inlet off of 3/4, and we want to exit the hot water into 3/4 inch tubing. And the place I have that, where I can mount the water heater, is right up here. This one here is cold water, and this one is hot water. So we're going to tie into those two pipes. This is a 27 kilowatt unit. This unit's going to have 3 8-gauge 240 volt wires going into it. So at 50 amps, so at full load, this guy is going to be running about 150 amps, which is pretty big. All right, so let's move on. Mount those boards, mount the plywood, all up in this spot right here, and then, okay, I've put in one nail right there. Okay, now I'm going to put the level on that. I'll put the level on it, I'll put a nail up there. Alright. Alright. Got the board mounted and the bracket installed. So we're ready to put the water heater on. Alright, here's what it looks like with the box on the wall. Okay, here you can see the panel is open. This is a 200 amp panel, and you'll notice this is where you normally would have your main circuit breaker, but my main circuit breaker's outside. This is where I added 350 amp circuit breakers here, and we're going to come in the panel on the side here. This is the cables that I ran. Go over to this section of the house. Getting back to the panel, I'm going to shut the electricity off outside. However, I'm going to set it up so that I can power this light so I can see what I'm doing. That way the panel will be totally off, because these right now are hot. So yeah, here's some of the supplies we're going to use. I'm going to use this piece of conduit to go from the water heater into this 4-inch square box, and then I'm going to run all the MC cables, the 8-gauge cables, into the box, and then go up into the conduit like this. See if I can. Anyways, there's 7 cables. No. Yeah, 2, 4, 6, 7 cables. There'll be 7 cables going in there, because the hot water panel only needs 1 ground. So we'll tie all the grounds together here and run 1 ground up to the hot water heater. This is the cover. Let's move that cover. Whoops. This is the cable cutter for the MC cable. It makes that very easy to do. This is my wire cutters. You got 2 push to fit. I don't think that's what they call it. Push to something or other, to put it on the pipes, and they'll run some 3/4 inch PVC PEX down to the hot water heater. Here's our clamps for the conduit into the box and into the hot water heater, and this is nails, holders for the PEX. So over here, I've already I just kind of put them together to get an idea, but braided lines for designed for hot water heaters, and then I put push to connect ball valves on each side. So then this will come up the side like this, and then we're going to connect up into the pipes up here. Okay. The electricity, I've run the electricity here. Coming down. And I labeled each one so that I know which one is which. As you can see, I actually got the labels labeled L1, L2, and L3, but since it's blue painter's tape written with blue ink, you can barely see, so I thought I'd throw 3 pieces of tape, or the number of tapes for whatever circuit it is, so I know. So it needs to be cleaned up. It'll be cleaned up. I work from the panel back to here. But they came up, and then I put a board up here to run the cable on the board, and then that's going to go, you can see it goes back over here, and then it's going to go on the other side where the panel is. The hot water heater is going to get connected into these 2 pipes. Okay, this pipe is hot water, this pipe is cold water, but so this little hot water heater though is 27 kilowatts, and again 3 50-amp circuits. If you don't have 200 amp service, you can't put, if you don't have 200 amp or more, this won't work. But this little hot water heater, you'll see how little it is, because here's my hand. And the next thing we're going to do is hook up the electrical. So I'm going to have to shut the power down into the house so that I can attach the electrical into the hot water tank, into the hot water tank, into the panel. And go from there. Okay, I shut the power off to the house, and I have this one lamp, LED lamp right here, and I got it right here, and it's hooked up to an extension cord that goes to my neighbor's house, because I couldn't find my inverter. I was going to use the battery pack I used to jump cars for 12 volts going into this portable 300 watt inverter, which gives you 120 volts out, and that would be enough to power an LED light. So anyways, there's nothing here now. Let me get my tester. Here's my tester. Here's my tester. And that's for power. Okay, those are the, oops. These are the guys running in from the main circuit breaker outside, and they're dead. All this is dead. See, now this has got power. See, so it's showing red, danger, beeping, solid lit, power. Over here, blue, cold, good stuff you can touch. All right, so I'm going to hook up these 3 cables and close up the panel, turn the power back on. We've got the panel closed. We've installed the circuit breakers for line 1, line 2, and line 3 here. You can see the cables going in. I got the cables labeled, and we got them going into the panel box there. All right, now we're just going to dress the cables and bring them over to the hot water heater. All right, we've got it wired, and also I've assembled the shutoff valve onto the tubing, on both tubings. These are just screwed in lightly right now, and what we're going to do is put in a push fit connector, and that's going to go up here in this section here. Okay, I got some preliminary measurements, but basically from the outside edge of the push connector in 1 inch, that's where we'll cut it. So the interesting thing is going to be when we cut the pipe here, or the copper tubing, is being able to move it out of the way so that I can put the push fit connector in. It's a T connector. It would have one here also on the cold water. So this one's hot water. Whoops. And this one's cold water. This is hot water, and this is cold water. How does a tankless hot water heater work? Well, it has a couple of sensors. We have on the cold water side right here, we have a flow meter sensor, which is going to determine if water is flowing through the heater. In other words, if you're at a sink, you turn the hot water on, the water is going to flow through the hot water system, and it's going to pull cold water through here. And when that happens, the flow meter is going to say, hey, there's water flowing. At that point, it's also measuring the temperature. So there's a temp sensor here for the cold water input, and there's a temp sensor on the hot water output. So the control board here is going to determine how much to heat the water. This section here, you can see the tubing. I don't know if you can see it there. This is the temp sensor here. So the tubing there, which is a lot smaller than 3/4 inch, but the water is going to flow through this heat chamber here. Okay. Okay. So if the water temperature is like 50 degrees coming in and you're asking for it to be 120, it's got to heat up within this heat chamber, the water another 70 degrees. So that's where the 3 electrical circuits come in. So it's going to draw from those electrical circuits, and 50 amps per circuit, that's a lot of current. So that you can get a lot of heat there. When you think about an electric stove, that's only a 50 amp circuit for a residential house stove to cook with. So we're trying to make water a lot faster, bring it up to temp real quick, but it's only got to go to 120, where a stove is going into 350, 425 and higher. All right. So next we're going to hook up the water. Well, actually next we got to shut the water off in the house and drain it. So it triggers, it triggers the unit on, and as you can see, it's heating the water up. And I shut the valve off, and it'll shut off. But anyways, there you go. What we have here is a chuck valve, and it shows the direction of which it allows water to flow. So up here might make more sense, which is like we did the T for, the shark bites. So we'll try that. All right, bring you up to the pipe, the tubing. It's 3/4 inch. Cut it with the pipe cutters, tubing cutters. Reamed out, reamed inside of that and inside of that, and then clean the outside. And now we're getting ready to put the valve in, the check valve. Okay, we'll go in like that. All right. So that's what we're gonna do next. It turns on pretty fast. For instance, I'll just turn it on right now by turning on a hot water faucet here. And as you can see, it turned on. And the water is heating up fast. You'll also notice that it looks like a spray, you know, a shower spray or something, but I guess that's supposed to signify that it's on. Water's running through it. So when water stops flowing through the unit, it eventually shuts itself off on this particular model after about 10 seconds. So it's actually a very simple item, other than it requires a lot of power.